to the next session on ANSYS CFD tutorials. In this session, we will analyze the Venturimeter for its fluid flow analysis. We will start by double-clicking on Fluid Flow Fluent. I'll first go to Geometry and right-click. I created the geometry in the previous session, so I'll directly import the geometry. Then I'll go to Geometry and double-click again. We want to add the fluid in this Venturimeter. So we'll go to Tools, Fill. It is asking for the faces that you want to fill. So I'll select them by pressing the Control button. Apply, Generate. So now you can see there are two parts, two bodies here. This is the outer solid. So I'll rename this as pipe. And the inner solid, as you can see, I will rename this as fluid. Once this is done, we'll close the window. I'll go to Mesh and double click. I'll first go to Mesh and change the default sizing to 0.01 meter and generate. So you can see here this type of mesh has been created. Now if you want, you can make this more finer. I will leave it to this itself. Then I will go for naming of the sides. This is the inlet. This is the wall. And this side is the outlet. You can see here inlet, wall and outlet. Just go to mesh and update the mesh once again. You get a message over here that mesh translation to fluid was successful. Once this is done, we can close this window. Then we'll go to setup and double click. Your solver processes, I will choose to start. We'll select gravity. Along the y-axis, I'll give the value as minus 9.81. Then I'll go to materials, fluid. I'll double click on air. I'll select fluent database. Here I'll select water, liquid as the fluid. Copy and close. Then I'll go to solid and double click on aluminium. I'll go to fluent database again. I'll change the material type to solid and I'll select steel as a material. Copy and close. Once this is done, I'll go to cell zone conditions, fluid. I'll double click on the fluid. I'll change the material name to water liquid. Apply. Close. Then I'll go to solid on the pipe. I will change the material as steel. Then I'll go to boundary conditions, inlet. I'll give the velocity as 2.2 meters per second. Apply and close. Once we give the boundary condition, we can go to reference values. I'll compute from inlet. Reference zone is the fluid. Then I'll go to initialization, standard initialization, compute from inlet, initialize. Then I'll go to calculation activities, auto save every iteration. Here I'll choose a number, let's say 20. Okay. Finally, I'll go to run calculations and double click. I'll give number of iterations as say 200 and calculate. The calculation is complete. You can see here it has converged. It has taken only 47 iterations to get converged completely. You can see this result over here. It is completely converged. Now this has given a good result in very few iterations. It doesn't happen always, but it has happened for the case of Venturimeter, and the reason for this is the shape. You can observe here, this is the converging section, this is the throat in between, and then you have the diverging section. The converging section is a very short one, and you have a long diverging section in case of Venturimeter, such that the velocity when it passes after the throat, it slowly reduces and goes ahead. Whereas the pressure, which has become vacuum in the throat zone, now increases. So there is the proper balance of velocity and pressure, and you are able to get a good converged solution for your model. So now we close this. Okay. We go to results and double click. Here I'll go to inlet and double click. I'll go to render. I'll change the transparency to 0.9 and apply. I'll do the same for outlet, wall and wall pipe. So once you're done with this, we can click on streamline. Okay. I'll start from the inlet. Number of points, say I give as 100. Apply. So you can see here the beautiful streamline that has been created. Now if you want to see this result, you should go to animation. Type is sweep animation. Select streamline 1. Remove the forever loop and give say 3 loops or 4 loops, how many ever you want. I'll change the speed to a little slower one and start. You can see here when it passes through the converging end, slowly the velocity is going to increase. In the throat area, the velocity will be maximum, and here the velocity again slowly reduces. At the throat section, your diameter is the minimum, hence your velocity is maximum. And when the diameter slowly increases in the diverging section, your velocity is going to slowly reduce. So this is done. You can untick the streamline and we'll click on contour. We'll create the first contour of say pressure. Location is contact region TRG. Range is local. Number of contours say I give as 50. I go to render. Remove the show contour line. Apply. Here you can see the beautiful contour of pressure created on the Venturimeter. At this end, the initial pressure is high. In the throat area, it is the minimum, and then slowly your pressure is going to increase. Your maximum pressure in red color, as you can see, is 4958.79 Pascal, and the minimum value is minus 42756.7. The negative sign will indicate vacuum pressure. Now this is done. We will create another contour, so I'll untick this one. I'll click on contour option again. OK. Here I'll change variable to velocity. Range is local. Region is your contact region TRG. Number of contours, say I give as 50. We go to render and remove show contour lines and apply. This is the velocity contour. Here you can see your velocity is varying. It is slowly increasing towards the throat area. At the throat section, your velocity is going to be maximum. Diameter is minimum here. Pressure is the lowest. Pressure is vacuum. And then when you go ahead, your velocity will slowly reduce till it reaches the pipe area. So this is the variation of velocity in your Venturimeter. And you must have seen the same kind of variation by using your theoretical method. The maximum velocity is 9.6618 meters per second, which is in this zone, and the minimum value is 0.72677, which over here you can see, where it is again merging into the pipe area, the water. So with this, I end the session. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.